Hello and welcome to episode 8 of C++ Weekly. I'm your host, Jason Turner. Once a week, I pick some topic of interest in C++ and dig into it with some live coding. In this episode, I'm going to discuss C++ name mangling. So let's start with this example. We're going to create a class that contains a vector of strings. And we need to include our proper headers. And then we need to create an instance of this class, an object of it. Now when we compile, we have this executable that was just created, and we might be curious what symbols were created in it, maybe if we're trying to debug compile times or something else. And we can use the nm tool to get a list of all the symbols. And what we're looking at here are the names that have been mangled by the compiler. That is, it takes some standard human readable name and it creates this compact thing that means something to it, but doesn't necessarily mean a whole lot to us. We can look through and we can see this has got a vector base, something that contains a basic string that uses car traits, something or another. So if we're on the command line on Linux, we can use C++ filt-t to say that we want to demangle all C++ type names. And then we can see that these type names are actually quite a bit longer than we would have ever assumed they are. So this is the destructor for the vector, which is a vector base of basic string, which is of type char, because there's actually several different string types, and the std string is actually a type def to basic string of char. And it's using standard default allocators for the char and for the vector and all kinds of things. And if we play around with this, we can see that these names can really quickly get out of hand. So if we just, for instance, had a vector of vectors, of lists, of pairs, of string to string, fill in all of our right angle brackets. 1, 2, 3, 4. And include our extra list. Yeah. And because we put our brackets together, we need to tell it we're in C++ 11. Now we run this again, we can see that this is just a ridiculous amount of mangled type information. If we don't run it through C++ filt, it's still a crazy lot and pretty hard to get through. All right. So the question is, and the point of this video is, what if we want to get the demangled name at runtime? There can be a lot of reason why we might want to do this. So let's just start with this. We want to use cout, and we need to put something here to get to what we want to get to is my class : m data. All right, so what is the something? The something, it turns out, is the type ID operator. So the type ID operator returns a struct of type info. So let's include type info. And we want to do type ID. And we can see that the type ID has this implementation defined name of type. So we're going to call that. So now when we compile our program, we forgot IOStream. Invalid use of non-static data member my class mdata. Pointer to that member. And missing semicolon. Okay. Now when we run it, we get printed out to the screen the mangled name. So with GCC, this is something that I'd actually been looking for quite a while, and I just found the answer a couple of months ago, and I have not yet put it to use. We can use the GCC ABI namespace, the GCC demangle ABI. So we have this function __CXA _ demangle. And that is in the, where's the header name? cxx abi.h. abi.h. And now we have access to this function that we can use to get the demangled name. And it is cxa _ demangle, mangled name. And it has two options. It can either return back to you a pointer to a buffer of the name that it allocated, or you can pass it a buffer that it allocates. But it is free to resize the buffer that you pass it, so I really don't see the point in why you would ever want to pass it a buffer. If it's going to resize it, then you're just going to have to clear it yourself anyhow. So we're going to pass it no buffer of 0 length. And we have to pass it a pointer to a status value. And let's see what that gives us. I clearly misspelled something. Oh, right. It is in a namespace of ABI : All right. And now we can get the demangled name. As we can see, because it's a pointer to a member, this is the type of the member. This is the class that it's a pointer into. All right, so we're leaking memory here, so we need to clean this up a little bit. So we're going to make our own function that returns a string and demangles a const char star mangled name. So we'll use this cxa demangle function. So we need our status integer and we need this pointer, which is actually not a const char star. And take this out. Okay, so now we need to if status equals null, equals 0, excuse me, then we want to create a string from the demangled name that we have. So it's guaranteed to be a null terminated string, so we can do this. And then we can, since that was created with malloc, we want to free the demangled name. And then we want to return our red-val. Else, let's throw an error. Okay. So now we should be able to call our demangle function and no longer have a memory leak. Let's see if this compiles. It did. And we get the same result back. Excellent. Okay, so this is how you can do demangling of C++ names in GCC, and the same option works in Clang, but you might have to install extra libraries to be able to, extra standard libraries from the Clang LLVM project if you are using libc++. And if you're curious about Visual Studio, it turns out that this is mostly unnecessary in Visual Studio, in which I've saved the output here, because while Visual Studio does do some name mangling, you only get that if you explicitly ask for the raw name in its type info structure. If you ask for the name value in its type info structure, like as you did in GCC, then you get a human readable name back. The only problem is that it prepends class or struct onto each of these things, which seems a little unnecessary to me and actually a little bit harder for me to parse with my human brain. All right, so thanks for joining me for this episode. As always, if you have any questions or comments, check out the website and leave me a note there, or you can find me on Twitter and let me know if you think these font sizes are all right this week.